Okay, this first slide is not in your notes, but it kind of shows you how the matrix works. A matrix is an arrangement of numbers in rows and columns. The rows, oops, I want this. The rows are horizontal rows. So this particular matrix has 2 rows. The columns are vertical columns. So 1, 2, 3. This thing has 3 columns. So this matrix is a 2 by 3 matrix. The order is 2 by 3. Order is basically the dimensions, the number of rows, number of columns. So on our next slide, this is the slide that you actually have, we need to determine the order of each matrix or the dimensions of each matrix. And you may want to write on your paper, row by column. Rows are horizontal, columns are vertical. So A, how many rows does A have? 2 rows by how many columns? 4 columns. It is a 2 by 4 matrix. How about B? 3 by 2 matrix. What about C? 2 by 2. And D? 1 by 3. It's a little weird when there's only 1 row, but there are 3 numbers, so that's 3 columns. Okay, so order of the matrix, super easy. Okay. Matrix addition. In order to add matrices, the matrices must be the same dimensions. They must have the same order. So this is a 2 by 2 matrix plus another 2 by 2 matrix. Your answer is also going to be a 2 by 2 matrix. Now here's how ridiculously simple this is. The top left answer is going to be found by taking the top left number plus the top left number. What is 2 plus -5? Okay. The top right number, 3, and -3 is 0. Bottom left comes from bottom left plus bottom left. That one would be 10. And bottom right comes from bottom right plus bottom right. 3. Ridiculously simple? Yeah. Okay. Scalar multiplication is also ridiculously simple. What do you think you're going to do with that 2 outside of the matrix? Multiply all of them by 2. So 6, -2, 8, and 4. Crazy simple? Crazy simple. Now, here's how the ACT does this. And I'm going to want you to add this example in. A times 1, 4, 3, 5 plus 3, 1, 2, 4 equals x 13 y z. So you might see something that looks like this, and they will ask you, what is the value of x plus z? And if you've never seen matrices before, do you see how this problem would be like, oh my gosh, I have no idea what's going on. I'm going to choose B and just move on. But this is basically scalar multiplication. So you know it's A times each of these things plus whichever one matches the position equals whatever you have here. So I see that we know 13, and I trace that position back. We can create the equation A times 4 plus 1 equals 13. And we can figure out what A is. So what's 13 minus 1? 12. And if A times 4 is 12, what is A? 3. So now we know that this A is really a 3. So to figure out what x is, we would do 3 times 1. What's 3 times 1? 3 plus 3. We just figured out that x is 6. And for z, if you trace z back, what is 3 times 5? 15. And 15 plus 4? 19. So what is 6 plus 19? 25. If you know how to figure out what this number is, or one of the missing numbers, you can use that to find the rest of them and then answer whatever question it is that is posed to you. Okay, at this point, we're going to stop the lesson, and on your worksheet, I will ask you to do numbers 1 through 9. If you are doing the whole lesson, then you would do the whole worksheet. But today, because of our assembly schedule, we're going to stop and just do numbers 1 through 9 on the worksheet.